Hello everyone, our group is Clownfish and our project is image processing. In this video, we will explain what we found to sharpen the image, to blur the image and to do the edge detection. We will also show some common filters in this video. The basic algorithm to edit the image is the formula shown in the poster. In this formula, V is the elements in the filtered image, and U is the elements in the original image. H is the element in the matrix which we use to filter the image. Let's see how it works. This one is the original image, and this one is the filter matrix. First, we put the filter matrix over the original image, and then we can get the first value in the filtered image, which is 1 times 0 plus 2 times 1 plus 1 times 0 plus 1 times 1 and so on. Then we get 7. Now let's move the matrix to the next column. In the same way, we can get the second value, which is 5. And then let's continue to move the matrix. We can get the third value, and we move it to the next row. We can get the fourth value. We move it over the original image. Then we can get the filtered image. Blur is the process to reduce the difference between pixels. Here we have two examples. The first one is box blur. After this filter, the resulting pixel is the average of its neighborhood. The second one is an approximation of Gaussian blur. After this filter, the resulting pixel is the weighted average of that pixel's neighborhood. And we also have some images. For example, the first one is the original image. This one is the resulting image after the box blur. And this one is the resulting image after Gaussian blur. Motion blur is the blur in one direction. To get this, we can find the average of pixels on a line with a specific slope. This one is the original image, and this one is the resulting image, which the angle is 90 degrees, and this one is the angle is 0 degree.
The principle of image sharpening is similar to the blur. It also uses the filter to edit the image. The sharpening filter could increase the difference between the edge of the image and other parts. Here are two very simple sharpening filters, and here are the results of these filters. This is the original image, and this is the sharpened image of the first filter, and this is the sharpened image of the second filter. And here are some other more useful filters. They have better effect. We take solver operator as an example. it weighs the pixels from different distances differently.
For edge detection, first let me explain the edge points. Edge points can be considered as pixel locations of abrupt change in pixel values. Then we can use a matrix to detect it. For example, this matrix is use the right pixel to minus the left pixel, which can detect the change in horizontal direction. Let's see the image. This is the original image, and this is the edited image. In this image, we can see the pixels in original image which have the same color or very close to each neighborhood become very dark in the edited image. This is another example. Use this method, we can find the edge in an image.
Let's talk about another common filter to transfer image to black and white. First, let's talk about what is RGBA. RGBA stands for red, green, blue, alpha. While it is sometimes described as a color space, it is actually the 3-channel RGB color model supplied with a 4th alpha channel. We can change a color directly by changing its channels. And in this, we use these filters. The basis algorithm is matrix multiplication. The filter we will use is called color matrix. The formula is the color matrix times the matrix contains RGBA and the offset of an image to change color directly. In this formula, M is the color matrix. Numbers in the color matrix are from 0 to 1, and row 1, row 2, row 4 is red, green, blue, alpha. Column 5 is offset, and C is the matrix contains RGBA and offset of an image. C1 is what we want to get. Every point in this picture needs processing, and finally we get what we want.